Okay, we're going to go ahead and get started. So thank you and welcome to today's Tech Talk. We're going to be talking about the smart Wi-Fi strategies for planning and deploying your APs for optimal performance in your environment. I am Marcus Holmes. I am the sales engineer here at Zyxel. I've been with the company for almost 18 years. And so today we really want to talk about the Wi-Fi strategies and deploying them in your environment. Now, I know I've covered this in a previous webinar that more focused on the wireless optimizer, which I will briefly touch on. But really what this is going to be about is focusing on what you can do to plan your Wi-Fi deployments and then what is going to be expected when you start to plan this out. And then additionally, we will look at ways to optimize the performance of the APs in the environment. So getting started here, let's go ahead and take a look at what our agenda is today. So first, we're going to talk about effective Wi-Fi planning. And what I mean by this is going to be talking about how do you plan for the Wi-Fi in your environment or for any projects that you're doing, what are the things you're going to be looking out for. The next thing after that, we'll be talking in the topics about using the Zyxel tools for deployment. And this is going to be the wireless optimizer. So it's going to be a pretty brief section and pretty short because I'm not going to go completely over the wireless optimizer or do a demo for it because I've done a webinar previously that covers how to import your floor plans and whatnot and getting the most use out of it. So I'm just going to briefly touch on that as part of your Wi-Fi planning. And then next after that, we will talk about the tips for optimization, what tweaks you can do within Nebula. And I don't know why this is actually a little wrong here. I do apologize for that. Header, it's incorrect. But we will talk about how we can optimize the Wi-Fi in the GUI of Nebula so that you can get the best performance out of your access points. Then after that, we'll talk about the common pitfalls for Wi-Fi, and then we'll open it up to a Q&A session. So let's start talking about the effective Wi-Fi planning. So when you get a new project, a customer comes to you or you're working for a customer and they would like you to deploy Wi-Fi in their environment, the first thing you really want to do is kind of understand your goals. Talk to the customer or your end user and find out what their goals are. Do they plan to have this Wi-Fi open to everybody? Are they going to do a guest network? What kind of environment are you going to be planning this out for? Is it going to be for a shop? Is it going to be for specific clients? You got to figure out what kind of environment this Wi-Fi is going to be used for. In addition to that, you need to think about how many SSIDs you think you're going to need. So are you going to be using this in a corporate environment where you have multiple SSIDs for, say, your marketing team, your sales team, your operations team, and then your management? So you really need to think about how many SSIDs you're going to deploy for your projects, keeping in mind that by default, all of our access points can use 8 SSIDs per radio. However, in Nebula, you can expand that out further with some options that we have available, including AP tagging, and then also the ability to do a prefix and a suffix for programmable SSIDs. So that means that you can have your access points have the same, using the model name for the prefix and then have a specific suffix at the end of it to kind of expand that out. But that's a little bit more on the complicated side. We can touch on that another day, but we do have the ability to expand out SSIDs beyond that, including SSID groups. In addition to that, you're also going to think about your SSIDs and VLANs because our APs do support VLANs. So you can tag your SSIDs with a specific VLAN so those users get put on a specific network. So these are the kind of things you need to think about because if your customer wants you to segregate your SSIDs, then you just putting them on a flat network with just, different SSIDs are still going to come from the same DHCP pool. They're going to come from the same DHCP scope. But you can put them on different VLANs so that each SSID is segregated. So again, understanding what the goal is, if you choose to go that route, which we highly recommend, is always to try to segregate your SSIDs for your clients. And then the next thing is to figure out exactly how many total devices. Usually when you get the question of, well, how many users are you going to have? You have to also think about a user might have more than one device. They may have a phone, a laptop, or a tablet, or all three. So you need to look at how many total devices and not the amount of users. This is specifically, very, very important for, say, a hotel environment, because if you're looking at on a room basis, You may have a 200-room hotel, and you're thinking, okay, I need to support 200 users. But that's not the case, because a hotel room can support maybe a family of 4, and each of those particular users now has an additional maybe 2 devices total. So in each room, you're looking at 8 total devices per room in a 200-room hotel. Now you're up to 600 devices, 200 times 8, so you have 1,600 devices total. So you need to think about exactly how many devices and not the actual users. So don't focus on the users, focus more on the actual total devices for the whole deployment. And again, is a guest network going to be needed? When you enable a guest network on these Zyxel access points, especially Nebula, what it does is 2 things, and that is it enables intra-BSS blocking and also enables layer 2 isolation. So these 2 things are key, because what the intra-BSS blocking will do on the guest network is that if 2 devices are connected to the same SSID, intra-BSS blocking will prevent 2 devices on the same SSID from being able to communicate with each other. Layer 2 isolation, on the other hand, will then take it a step further and prevent clients on the SSID from accessing devices on the LAN side. So anything connected to a switch, the AP is connected to a switch, and there's another device connected to that same switch, it'll be blocked. And that's where you're going to need a whitelist to enable that device to be able to be seen. If it is a printer that's shared, you have to put that information in. So something to think about: is a guest network going to be needed for the deployment? And then you have to go through the steps to make sure that that guest network is set up properly. Now, there is a toggle in Nebula to enable guest network that automatically turns those options on. However, you will still need to whitelist specific devices that need access across the guest network, including the remote gateway, or actually the upstream gateway. So if you have a firewall or some kind of router at the head of the network, that device will be needed to be whitelisted. And then lastly, for your goals, is to figure out exactly what's the area that needs to be covered. So is it a warehouse? Are you covering a specific space? Are you covering an office? Are you covering just a conference room? So you need to understand what needs to be covered in the area so you can start thinking about your planning. Now let's talk about what technical challenges you have for Wi-Fi planning, okay? What's going to be the incoming speed of your gateway? What is the ISP giving you in terms of your ISP throughput? That's going to really kind of tell you what kind of access point you're going to need. So if you have a 1 gig pipeline coming in, you may not necessarily need a 2.5 gig AP or AP that's capable of those types of speeds, unless you're more concerned with your local traffic. Like if you have a server on the internal part of the network, and most of the type of traffic that is required is mostly internal, then you might want to start thinking about a 2.5 gig access point. But if it's purely clients that are just going out to the internet and they're not communicating with other devices, but your ISP is only at 1 gig, you may not necessarily need the 2.5 gig access point, but you can still get that 2.5 gig multi-gig AP to future-proof in terms of the ISP actually offering something a little bit more faster. So that's going to be a conversation that you have to have with your customer or your client to kind of figure out, hey, are you planning to upgrade in the future? What's your ISP speed? Can we get you on something faster? These are the kind of things that a lot of customers don't really think about and the clients don't think about, but that's something that you keep in the back of your mind is what is going to be their upgrade path. The next thing is going to be is this going to be all indoor, outdoor, or a mix? So if it's all indoor, of course, you're going to focus on indoor access points. If it's outdoor, say for you're covering a park or some kind of event, you need to look at your outdoor access points and then think about what kind of antenna you're going to use. If you're going to bridge it from one access point to another or do a bridge plus access point, you then have to think about what kind of antenna am I going to use? Am I going to use an omnidirectional or directional? If you're doing a point-to-point bridge, we always highly suggest that you get a directional antenna so that your connection between the 2 access points is solid. Your omnidirectional is going to be wasting a lot of power going outward, but your directional is going to be from one side to the other. And then next thing to consider is your wall material. What are you trying to blast your AP signal through? Do you need to go through brick? Do you need to go through sheetrock? What kind of material in the walls and also in the floors, if you're, trying to push signal between floors, what kind of material are you using? That's something to take into consideration because, as the AP penetrates specific type of material, you actually do lose some power as it goes through. So always try to take that into consideration as best as possible. Now, another thing a lot of people don't really consider is, are there other access points in the area? This is something that you have to do with a site survey and using a tool like Insider, INSSIDER, a nice little program that allows you to do a site survey and see what other access points are in the area. So with that utility, you'll be able to see if there's another AP in the area, and then you can see what channel it's broadcasting on, and then you'll know to avoid using that channel in your deployment. To give you an example, a few years ago, we were presented with a project to help a customer install some access points in a mall, or sorry, it was a shopping mall, but they had a hotel above the shopping mall, and the shopping is like an indoor, like a small little shopping mall, maybe about 10 stores, but each one of those stores had their own off-the-shelf router in it. So there was a lot of Wi-Fi signal, downstairs that was bleeding to the floor above for the hotel. So that creates a challenge because you don't have access to change, the access points downstairs in that particular scenario. So you have to be cognizant of what other APs are in the area, and you have to kind of work around that. Because if you don't think about that and you don't kind of plan for it, you might install an access point and then you set up your channels for your access points and then find that there is a lot of interference going on. There's a lot of channel interference from other devices that you have no control over. So you kind of have to think about what other APs are in the area and try to work around that. Next up is client density. So you have to think about what kind of density for your clients are going to be set up in a particular space. So if you're covering a convention hall, you have to look at how many client devices you're going to support and then think about how many access points are going to be needed. And that's something that we're going to talk about here on the next slide, is understanding Wi-Fi and understanding some of the limitations, I'd say, with Wi-Fi. So, of course, Wi-Fi is only half duplex. It's not full duplex. It can only send and then receive. Now, we can get around this by having multiple spatial streams. We can have, a 2x2, a 3x3, or a 4x4 radio. That does help out. But, that half duplex does you have to take that into consideration. The next thing we have to talk about also is the client radio power. So a lot of people tend to ask us, well, how far does your access points go? How far can they reach? Well, to be honest, our access points can reach rather far. They can reach 3, 4, 5, even 600 feet under perfect conditions. The problem is not so much the access points, but it's the client devices. The access points have far more power than the client devices have. You kind of have to think of a scenario, which is my favorite scenario to explain this, is you have a major league pitcher throwing a ball to a child. The major league pitcher can throw the ball very, very far, but the child may not be able to really throw the ball back as far. So your access point can reach very far. The client devices, whether it be a laptop, an iPhone, Android, tablet, what have you, those devices, their radios aren't strong enough to throw the signal back. They can catch it, but they can't throw it back as far. So that's why you end up seeing, little signal as you reach a specific point. So our rule of thumb when it comes to our access points of what we've seen in client devices is that it's about 125 to 150 feet radius in terms of how far the reach is with the access points based on client devices. Now, if you're doing a point-to-point solution, that's a completely different beast altogether because you can cover hundreds of feet with that because you have an access point that has a radio that's strong enough to catch and throw back the signal. The client devices, not so much. So that's why we usually say 125 to 150 feet radius in all directions for the access point to reach. And then lastly, our suggested clients for AP. You can actually load up your access points to the full maximum, 255 clients or 512 on certain ones for the wireless association list. The problem is that once you cross the threshold of about 50 to 75 client devices, that's when the speed begins to slow down. Because with all the spatial streams and it being half duplex, there's a limitation of how much it can send and receive at any given time. And so at about the 50 to 75 user mark for regular web browsing and whatnot, that's when you start to see a drop off. So that's usually our suggested clients per access point, 50 to 75. 75 is really, on the edge right there, but it's really going to be dependent on what kind of traffic you're sending. If you have a very, very low packet application, maybe IoT, then you can actually load up more clients than the 75. But if you have someone that's using it in an office with basic web browsing, maybe sending some files, you want to keep it in that 50 to 75 clients per access point range, just because once you hit that threshold, the speed begins to, the maximum throughput begins to drop off sharply. Now, let's talk about the wireless tools for deployment. Now, again, I talked about our wireless optimizer, which is a tool that you can use to upload floor plans and check your AP coverage. So if you have a floor plan that was given to you by the customer, you can load it into the wireless optimizer. And then at that point, you can use a specific tool to measure out the distance on the floor plan, and then it will scale up or scale down the floor plan properly to the right ratio. And at that point, you can start dropping access points on, and it will give you a heat map. Now, this is primarily used for pre-planning. It doesn't take any live data. It doesn't account for walls or anything in the environment. It's just giving you a rough guesstimate of exactly where you should put the access points. And then once you get on site, you can do a site survey to then kind of tweak their placement. But this just gives you a general idea for pre-planning where your access points should go. So I would not take this as 100% accurate. It's just a good pre-planning device or a pre-planning software that you can use to try to figure out what's the best place to put the access points, just to give you a general idea of where you should place them. And again, it doesn't use live data, and it just gives an estimate of your coverage. And so what you can also do in the wireless optimizer is you can adjust your power output just to kind of give you an estimate of what your power output looks like. So for instance, here's a quick floor plan that I did earlier. So what you'll see is that we have a floor plan here. I placed the access points in, ignore the channels that are being shown here, but it shows you the coverage of the heat map. Now, this section here was about 250 feet on the width here. However, because these access points are very strong, I had to turn the power down. So I turned the power down to about 6%, but you can see how far that they broadcast. And then you'll see here in the bottom right, it shows you here what your dB levels are. So you'll see at about 78 feet, it's saying it's about -70 dB. That's usually within spec. But again, we're looking at, at 12, I think it was 12 or 6% power. You'll see that it's shrunken the total radius of this particular access points, just so we can fit it within the particular building, so we don't have too much bleed over. And then what you'll see here, and something we'll talk about, is our dB numbers. What's the best optimal dB threshold? That's something that you can actually set in Nebula, which we'll talk about here shortly. But this just gives you a general overview of what your Wi-Fi heat map will look at in the optimizer. It's a really good pre-planning tool, but again, it's not 100% accurate. It's just specifically used for giving you a rough idea of where to place the access points. And again, you can just place these access points all over the map where need to be, and you can check for your 2.4 and your 5 gigahertz for the access points. Now, let's talk about the tips for the optimization. And for that, we're going to go to our live GUI demo. So I'm going to go ahead and switch screens here so we can go to look at our Nebula dashboard. Okay. So now you should see my new Nebula window here. So this is a Nebula dashboard for our access points, firewalls, and gateways. So on the left-hand side here, we're going to go over to configure, and then we're going to drop down, see we have our access point here. So the first thing we want to take a look at here is our radio settings. So on our radio settings, we have a little bit of things that actually a lot of things that we can do here. So this is from our demo. It's set to Germany, so we'll just ignore the country settings for right now. But here we have an option for our deployment selection. Now, whenever you're doing multiple access points in a small space, let's say that you're going to do a conference hall, and that conference hall is maybe 200 feet by 100 feet. Okay, that seems pretty big, but one access point could actually cover that whole conference hall, that whole for the whole conference. But 200 by 100, it would be able to cover it. You just pop an access point in there, it'll cover it. Problem is, using that maximum users per access point, if you have that particular hall and there's 200 people in there, well, then you're going to need to put multiple access points in there. You're going to need at least a minimum of 3 APs to have the best overall experience for the Wi-Fi. Not so much coverage-wise, but it's more of how many devices do we need to put in that particular space to cover the amount of clients that are going to be present. So for that particular hall, we have such a small enclosed space with 3 access points. At that point, what we can do is change the maximum output power of those access points. So in Nebula, we have our deployment selection, and we have a custom one, or we have multiple density options that are already built in. So if you have a low density of, say, 2 to 5 APs, you'll notice that it actually drops the power down. Usually, depending on channel, you can get up to about 27 or 30 dBm, but you actually end up lowering it based on this particular low density option. Now, you can use what's built in, or you can actually play around with setting yourself and set the dBm yourself. So this is something that you would have to play with to find the optimal setting. So if you have your access point set out maybe in a triangle configuration to cover that hall, you have one access point at each of the vertices of a triangle overlaid over the floor plan. What you can do is then set your maximum output power for your APs. And of course, since Nebula already supports roaming by default, what you can do is use a program, again, like Insider, and walk around and see that point to which it will then roam over to the next access point. So what you want to do is you want to try to lower your dBm to the point where you're covering a specific space, that the access point can have its heat or its radial signal go to a specific point. And then at that point, you have a cutoff to where it then connects to another access point. So this is something that you have to play with. There's no hard or fast rule to go by. It's going to be very different for each environment, so you have to adjust this as you see fit. Now, what I would suggest is that for the 2.4, putting it at least 3 dBm higher than the other radios. So, for instance, 2.4 could be 7 dBm. 10 gigahertz would then be 10, as seen here, and then 6 would be 13. And the reason being is that 2.4 has a further reach than 5 gigahertz, and 5 gigahertz has a further reach than 6. So doing it this way, at least your 2.4 is stronger, so it's going to be less power. Your 5 gigahertz is not as strong, so it needs to be stronger, and your 6 gigahertz is the weakest of the 3, and you want it to have more power. So these are just something to think about. You may need to adjust these up or down depending on the environment, but this is something that you need to think about when it comes to your deployment. Another thing we're going to do is look at our DCS settings. Now, DCS is your dynamic channel selection. So with dynamic channel selection, what you can do is have the access point look around the environment to determine what is the best channel or the most optimal channel to broadcast on. So you can have it set to a specific time to kick in every so often. I highly recommend not doing this and setting it to a specific schedule. So here we have DCS schedule enabled, and it's set to every day to check at 3 o'clock in the morning. So at 3 o'clock in the morning, it'll scan the whole environment and then automatically set each access point up with its own specific channel that is best for the environment. And then here we have our DFS channels. So your DFS channels are going to be the channels that are used on 5 gigahertz that are used by government agencies. This means that your weather radar, anything that's used by the military or government, there are specific channels that are labeled as DFS. So in order to see those DFS channels, what you can do is come down to manual. For 5 gigahertz, hit manual, and you'll see that these are your DFS channels here. Okay, so let's change this to all available channels for that one there. And then here we have our specific DFS channels. And I believe for this particular one, it has a certain one blacklisted originally, so it's not on the list. But these DFS channels are the channels that are operating on 5 gigahertz that are used by the government. So if you are using any of the DFS channels and you're broadcasting and say the government needs to use weather radar or broadcasting on 5 gigahertz, that means that if you are within the area, by law, the AP will have to shut itself down for half an hour. So if it detects radar from a specific source, it will then shut off the radio for half an hour. So you don't want your 5 gigahertz to shut off. You want to avoid DFS channels as best as possible. So here we have avoid DFS channels on the 5 gigahertz. Okay. Then down here is going to be one of the most important settings for your roaming. Now, again, we have roaming enabled by default, but the thing about roaming is that roaming is more dedicated to the to the client devices. So the client devices, the radios built into your phone, your tablet, your laptop, those Wi-Fi radios have built-in roaming aggressiveness, meaning that it will decide when the signal is too low and when that low threshold will trigger the client to look for another SSID to connect to. Now, because there is no defined rule for every single Wi-Fi card out there, some Wi-Fi cards have a more aggressive setting, some of them have a least aggressive setting. And what I mean by that is, a device may only disconnect and look for another access point once it reaches a specific threshold. And by that time it reaches that specific threshold, the signal is so weak. So instead of relying on the client devices to determine when the best time to roam is, we can do it on the AP side by using smart steering. So with smart steering, what we can do is we can set up a disassociation threshold. And what that disassociation threshold means is that whenever the AP detects that a client device hits that specific dB range, it will then forcibly remove that client from the AP and blacklist it for a short period of time until such a time that its dB levels are at an acceptable range. In doing so, that forces the client device to then seek for a better SSID with a higher signal. So here in 2.4, if we have this set to say -68, that means that on the 2.4 gigahertz side, when a client is walking away from the access point and its signal starts to drop and it drops to -68, at that point, the access point will send a disassociation packet to the client. The client will then disconnect. It won't be able to connect back to that AP with its MAC address because at that point it's been blacklisted for a short period of time. And then it will seek another SSID to connect to with a stronger signal. So -68 is a good testing point because -68 is found to be the threshold for VoIP traffic where you don't drop any packets, for streaming media in most internet applications. So -68 is a good testing threshold to go by. Now, as I spoke of earlier with the 3 dBm separation between the radios, we want to do something very similar here. So for 5 gigahertz, if we want to keep our -68 for 2.4, we want to go to -65 because, again, the lower this number is in terms of the numerical value, not the actual negative value, but this basically means that it's a higher value because it's closer to 1. And the same thing for the 6 gigahertz, we want to make this -62. So that basically means that we're going to disassociate if on 2.4. Once they hit -68, -65 for the 5 gigahertz, and then -62 for the 6 gigahertz. And then that will forcibly remove the client from the AP association list, forcing that access point to look for a stronger access, or forcing that client to look for a stronger access point to connect to. So again, these are some things that you will have to play with. It's best to do this while you're on site because you can walk the property and find what your sweet spot is. These are just guidelines to go by as starting points. It's really going to be based on your environment. It may be lower, it may be higher, but this is definitely a good place to start in terms of setting up your smart steering. Now, lastly, for what we can do is we can go over to our AP and port settings. And what we can do is set up AP load balancing. So AP load balancing allows us to put a cap on the amount of clients that can connect to an access point. So we have two different options here. We have Smart Classroom and we have Enable by Client Device Number. So if we enable by Client Device Number mode, we can then specify the maximum number of clients that can connect to each radio. So here we can say we want 50 for all three. And then we have this option to disassociate client when device overloaded. What this means by enabling this option is that you have 50 devices currently connected and associated. If a new member or a new client tries to join the SSID, if this option is enabled, the access point will look at its association list and look who has been associated the longest. So if there's a client that has been associated for a full day and it has the longest association time, with this option enabled, it will then remove the client that has the longest association time to make room for the new access point. If you want to do a hard cap, that's enabled by Smart Classroom. And the reason why this option is here is because for a Smart Classroom, you have a teacher, the students have tablets, there's a set number of devices per classroom. And at that point, if you have an access point in each classroom, you know exactly what the maximum number of devices that need to connect is. But at that point, you just hard cap it at the amount of devices for the classroom. So this is just a basic overview of how to handle and how to increase the performance of your Wi-Fi. Now, there's a couple of things we want to also look at as well when it comes to pitfalls and troubleshooting. So one of the most common pitfalls that we end up seeing comes to the logging. Now, unfortunately, I don't have the logs to show you this, but one of the things we tend to see in the logs when it comes to access points, and we might have some here, but let's see if we have some here. One of the things we tend to see in our event logs for the access point is association and disassociations, and this one doesn't show any, but in the logs you'll see just constant association, disassociation from the same MAC address over and over and over again. Whenever you're seeing something like this, and you might get a client that complains that, hey, you know, I keep getting dropped off the Wi-Fi or it keeps disconnecting, that might actually be a sign that you have a client that is between two access points, and those access points are fighting over the client. So it's associating to one access point and then disassociating and connecting to another. It's flip-flopping back and forth between two APs. So if you're seeing that in the log, that's usually generally what it means, is that you have an AP fighting over, so you have two APs fighting over a client, and the client doesn't know which one to stably connect to. So if you happen to see that, that basically means that either A, you need to adjust the access point's power so that they're not overlapping, or B, you may need to actually move the access point to a different location. So some of the tools that we do have to help kind of guide us with that is under monitor, we have something called wireless health. So with wireless health, what we can do is actually take a look at the patterns of disassociations or bad connections. So if I bring this up, let's see if there's anything on this particular location. Nothing bad, everything looks good here. Let's see if we could try switching sites and see if we can show a graph with a little bit more bad connections. There we go. So here, at this particular location in the demo, we have the Nebula portal reporting bad connectivity for specific devices. So what we can see is that it's a specific access point. So we have a lobby AP, the WAX650S, that has gotten 82 alerts, meaning that there has been poor connectivity to a specific client in the last 30 days. So what this tells me is that it's possibly a specific client. What we can do is look down here at the bottom and go down to the last 30 days, and we can specify and see if it is a specific client. So we have two clients. One particular, David's laptop, it shows, is having a really hard time connecting to that particular AP. Now, if this were a hotel, and we know that that AP is pretty far from where that room is, we would then say, okay, well, we may need to add another access point to that particular room. So if this particular user was at a hotel and they were in a specific room and they're getting all these alerts, we then would say, okay, well, it seems like we do need to put an AP closer to this particular room. If you keep seeing this over and over again, so over a 30-day period, if you have specific clients checking into a specific room of a hotel and they keep being tied to this particular room, then you know that you need to add another AP. Now, this wireless health is a ProPack feature, so you will need to have ProPack installed on your organization in order to get this particular sets of data. Another common pitfall that we tend to see when it comes to the access point deployment is thinking that an access point can reach into the far corners of a specific room when it's not. If you have an access point that has to penetrate multiple walls, it's best to do a site survey, again, to see exactly how far the AP signal can penetrate, because as it goes through multiple walls, it may not reach its intended destination. So again, doing a site survey, walking the property or walking a particular room to see what the AP reach is going to be after the AP is installed will help determine where your dead zones are and whether you may need to add another access point. Okay, so from here on, I'm going to go ahead and leave the floor open for any questions that you may have. So if you have questions, please go ahead and type it into the webinar chat. And then I will go ahead and leave this webinar open for another 5 to 10 minutes, just in case you want to ask any questions, and I will be here to answer them. But if not, you are free to leave the webinar, and then I will see you on the next webinar later on this month. But for now, I will go ahead and leave the floor open for questions. All right, I did get one question here. Somebody asked the 50 to 75 user rule, is that specific to Wi-Fi 6 and Wi-Fi 5? Yes, actually it is a little bit specific to that particular technology. As Wi-Fi 6 becomes more prevalent, Wi-Fi 6 does have tools to actually help increase the maximum amount of users that you can put on an access point without affecting the speed. But in order to get that feature out of Wi-Fi 6, every client device on the network needs to be a Wi-Fi 6 device. So if you have a mixture of Wi-Fi 6 and Wi-Fi 5, you can't take advantage of that because it's going to muddle up things by having the Wi-Fi 5 devices. So as you input or as you have more devices or all your devices as Wi-Fi 6, then you can actually take advantage of the throughput by loading up more devices on the access point without having it be affected. Just because of the advancements in Wi-Fi 6 and also Wi-Fi 7, specifically the fair time area usage on Wi-Fi 6, that makes it a lot more easier to communicate with multiple devices without affecting the overall throughput. So yes, once we have more widespread adaptation of Wi-Fi 6, you will start to see that rule kind of slip away. We are expecting that this year, at least an 80 to 85% market share of Wi-Fi 6 clients out in the wild. but I don't think we're going to get 100% and probably until next year. So as older devices are being phased out, older laptops, older phones are being phased out, we're seeing more Wi-Fi 6 chips in our everyday lives. And as we get to the point where we have 100% saturation, or that your business that you're working with or the client that you're working with, they all have Wi-Fi 6 devices, then you can kind of up that number. But for right now, 50 to 75 is the baseline. Where can you get the tools for the tools for management placement, the Zyxel tools? If you go type in, it's kind of hidden on our website, but if you type in Zyxel Wireless Optimizer into your search engine, it will actually pull up the direct link to our website to download the software. You'll just need to put in your email address, and then it will send you, I believe it'll send you a link, or you can just click on the link on the page to download the software. Radio settings for max output power. Should the settings be in intervals of 3, or is it in percentage? It's in intervals of 3 because it does it every dB fluctuation. So it's going to be not percentage, but in actual intervals. So when you're going from 25 to 22, that's in order of dB, it's not percentage. For the Zyxel management placement program, what kind of floor plans are supported? It supports JPEG, bitmap, I believe, and then PDF. So it supports those image formats for placing it into the optimizer. So if a customer gives you a PDF of their floor plan, you can actually import that. Another feature of the wireless optimizer for the planning is that once you've kind of gotten an idea of where you want to place the access point, there's a list where you can select the model that you're using, and of course that will change the heat map of how far theoretically the access point could reach. But when you're done with the wireless optimizer, there's an export feature that gives you a bill of material that tells you exactly how many access points total for the project, and then also you can input the channel for each access point, and you can also label each access point as a specific thing like hallway or classroom, so that when you have your bill of material, it spits out a PDF that shows you the picture along with the amount of devices that are going to be needed for the project. What is the best time for the dynamic channel selection? Dynamic channel selection, the best time to use it is going to be based on the environment and based on what the business hours are. We always suggest to run your dynamic channel selection before business starts or when there's the least amount of traffic. So if you have a 24/7 operation, you want to find a time that has the least amount of traffic so that when it runs the DCS, it doesn't slow down any mission critical operations. So again, before hours or wherever you have the least amount of time for the least amount of traffic, whenever you have the least amount of traffic on the network. Okay, for wireless health, you mentioned ProPack. How does the ProPack work? So for the ProPack, you actually have to have it for the full organization. So that means that every device within your organization needs to have the ProPack license. So if you have multiple sites that are tied to the same organization, that means that all those sites need to have ProPack as well. So that's why we usually should suggest that if you're managing multiple clients, each client should be their own organization instead of being a site under the same organization. The reason being is that, let's just say that you put yourself as the organization and you're handling 2 different clients. Well, if client A wants ProPack and client B doesn't want ProPack, well, you can't put ProPack on client A's site because it also requires client B to have ProPack on their site. So that's why we always suggest that each of your customers are set up as an organization that has their sites underneath that. That way, when you have ProPack and if a customer wants ProPack, it's bound only to that particular organization that's bound to that customer. And that way, you don't run into an issue where if a customer wants ProPack and somebody else doesn't, they won't be affected by it. Okay, I'm going to go ahead and leave the Q&A open for another 2 more minutes. I'll try to get optimizer logistics info, but no download leak. Let me talk to our sales to see if because usually when you put your contact information, it goes to our sales team. I'll have to check with them and see if they can send you the link directly. Because usually I know that sometimes it's kind of iffy on the website. Sometimes it does pop up with the link, and sometimes it doesn't. So I do apologize for that. Let me see if I can actually give you the direct link. Give me 1 second. Okay, good. You got the link. Okay, perfect. Okay. With that being said, I'm going to go ahead and close off this session. I do thank you for joining this webinar. I will be doing a webinar either later this month or the beginning of next month to kind of go over more firewall and more security best practices. So I look forward to having that webinar with you. But until then, you guys have a wonderful day. And again, thank you for joining the webinar.